Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up on two sample proportions, and we're going to be looking at running a two sample confidence interval. This will be from your notes spiral. And the scenario is election polls. In an early election campaign, a random sample, okay, random, that's good. That means we have our first condition there of 800. So it sounds like our first sample is 800. Registered voters showed 460 in favor of the candidate. So it sounds like we have a X1 of 460. Just before the election, a second poll consisted of a random sample. Okay, so now that we have two polls, we know that we're working with a two sample of some sort. And since they don't mention mean anywhere in it, it must be proportion, a random sample of 1,000. So the second poll is 1,000. So I'm going to write N2 equals 1,000. Registered voters showed only 520 expressing the preference. Okay, so X2 is 520. There are more than 300,000 registered voters. That right there, 300,000 sounds like my population. Create a 90% confidence interval for the difference. That's a key word there. Difference tells us that we're subtracting in the proportion of voters who support the candidate. All right, so we already know that X1 is 460, N1, the sample one, is 800, and they didn't give us P hat 1, but don't forget P hat 1 is just X1 over N1. So if we take the 460 and divide by 800, we get 57%. So about 57% of the voters are in favor of them there. And then over here, we have 520 that are supporting them out of 1,000, and 520 divided by 1,000. Oops, 520 divided by 1,000 is 0.52. And once again, P hat 2 is X2, the number supporting them, over N2. All right. Our formula is simply sample of the first proportion, and that was 575, minus the second one, the second sample proportion. And then, of course, we have all p hats here because we're working with a confidence interval. So we're always working with the sample proportion. If this had been a hypothesis test, this would have been completely different. All right. Um, the one thing we don't have for this, because we have p hat 1 and p hat 2, which show up all over, and we have sample size 1 of 800 and sample size 2 of 1,000. What we don't have is z star. Well, they wanted a 90% confidence interval. So this is the same way as it was for one sample proportion. We're going to go to second vars, inverse norm, parenthesis, 1 minus 0.90, close parenthesis, and divide by 2. And our mean is 0, standard deviation of 1. And we're going to be starting from the left. And we get 1.6448, which is what we have right here. And once again, the 0 represents the mean, the 1 is the standard deviation. And remember, the reason we have 0 and 1 is because we're working with z-scores, and all z-scores have the same thing. So this is 1.6448. Let's go ahead and run that test. So stat test. And we're going to have to scroll all the way down to letter B, which is two proportions z interval, and we're going to need to input our information. So there's our 460, the 800, the 520, and 1,000, and then we want a 90%, so 90 divided by 100, and we get 0.9, and we end up with a 0.01625 to 0.093. So about a little over 1.5% to not quite 9.5% change. All right. So there's our plug-in. And all we did was plug in all of our values. And this, of course, is what we calculated. Now, the question is, how in the world did we come up with this 0.055? Well, that all we did is we took p hat 1 minus p hat 2. So let's do that real quickly and see if that's what happened here. So we're going to go 0.575 minus 0.52, and we get 0.055. So about 5.5%. Because if we change that to percent, it'd be 5.5%. All right, so we're going to have a lower bound and an upper bound. And once again, that's just p hat 1 minus p hat 2 as shown there. And we ran that test, which we already did. We said it's a two proportion Z interval. We went to letter B. And when we did that, I'll just do it again real quickly without going through everything. This is what we got, 0.0162 as our lower bound and 0.0937 as our upper bound. And we just truncated right there. Okay, so we have our interval, which is great, but we still need to run our conditions to make sure this was actually that we had everything taken care of. Well, to do that, we have to have two random samples. They need to be two independent random samples. We have a random sample here, and then we had a second random sample. So it appears we have two independent random samples. One's of 800, and the other one is of 1,000. So both of those are taken care of. We know we have 300,000 voters, and that takes case for both of them. So 800 times 10 is 8,000. That's definitely less than 300,000, so we're good to go. And then 1,000 times 10 is 10,000. Well, 10,000 is also less than the 300,000, so we're good to go on that one as well. So N is less than 10% for both of them. So we know our sample's not too big, but now we need to make sure it's big enough. And this is where we're going to go N times P hat 1. N times P hat 1. So 800, that's our N, our sample size 1, times our P hat 1 of 0.575. 800 times 0.575 equals 460. Well, that's greater than or equal to 10. So that part's taken care of. And now I need to check it for the 1 minus part. So 800 parenthesis 1 minus 0.575. And that's 340, and that's also greater than 10. So we're good enough there. So that one's good enough, but I need to check the same thing on the other sample. Well, the other sample was size 1,000, and p hat 2 was 0.52. So that's 520. So that part's large enough. And then it's 1,000 parenthesis 1 minus the 0.52. And now it's 480. So that's large enough. So in this case, both samples are large enough to go ahead and proceed. Well, we went ahead and proceeded already, and we calculated that as our interval. So we need to define our parameter. And we will do that in the note spiral, and we'll do the conclusion later on in an exit ticket. But that's basically what I needed to check on you guys. Hope that helped. Look forward to seeing you on the next one. Thank you.